G484 homework booklet question 10. So we start off with an inflated football with a radius of 0.11 meters and a temperature 17 degrees C. We're asked to calculate the mass of air in the ball and with the pressure. So what am I thinking there? I see a radius, I'm thinking volume. It's telling me a temperature, great. I'm after a mass, and I've got a pressure. Well, from pressure, volume, temperature, I'm thinking PV equals nRT. How am I going to get a mass? Aha, they tell me the mass of 1 mole. So that's going to do everything I need to do. A lot of steps here, hence it's a 4-mark question, relatively large number of steps. Going to need to start off by working out the volume. I'll do that as a separate calculation. Volume of a sphere, 4/3 pi r cubed. That is in fact in the formula booklet. And that brings me to 5.58 times 10 to the minus 3 cubic meters. I then do PV equals nRT, the pressure from the question, the volume that I've just worked out is equal to N, the number of moles, times R, the molar gas constant, again in the formula booklet, times T. And I probably should have done this as a separate calculation on the side. I've got 17 plus 273 getting me to 290 Kelvin. If you do not use 290 Kelvin, you're going to get precisely no marks for that question. I can't believe it. They've allowed 2 out of the 4 marks if you use 17 rather than 290. What's the world coming to? They're getting slack. Okay, so you can calculate N from that, 0.602 moles. Once I know the number of moles, I hope it's self-evident really that the total mass I'd want would be the number of moles multiplied by the mass of 1 mole, and I get through to 0.0169 kilograms. We then said the football's left in a room at a temperature of 0 degrees until it reaches thermal equilibrium. First of all, what does that term thermal equilibrium mean? If something's in equilibrium, it means that there's as much flowing one way as another. And so perhaps the best description of thermal equilibrium is no net flow of heat between the objects. You could also simply say that they're at the same temperature, because if things are at the same temperature, there will be heat energy being exchanged, but there will be no net flow of heat between the objects, so it comes to much the same point. We're then asked to calculate the pressure exerted by the air inside the football when the temperature drops down to 0 degrees C. P upon T is constant. We've got a constant volume of the football, so we've got P upon T is constant. You could use the full PV upon T is constant, and your volumes will just cancel off. You could, in fact, I think, go to PV equals nRT again, just more complex than it needs to be. So the pressure that we had before, the 2.6 times 10 to the 5 divided by the temperature we had before, the 290 Kelvin, is the pressure we were after divided by the 273 Kelvin, multiply it by the 273 both sides, and you end up with the final pressure is that value, 2.45 times 10 to the 5 pascals. So relatively straightforward finish to G484 homework booklet question 10.